Uh, Hello, good morning. My name is Pedro Andrez, and first of all, thank you for being present. So this is the first time I'm talking to so many people, so be gentle with me. So I work for Mercedes-Benz IO, and I'm here to present you how we built a JVM-based cloud-native API gateway. So the session will follow more or less this plan. So first we'll talk about who we are and what we do and why we needed an API gateway. Then the objectives we had when we developed this gateway, and then we'll go over the overall architect, going in depth into each of the components. In this solution in depth, we will also have some live demos and showing up some segments of code on how we achieved some functionalities. In the end, we'll have some time for some questions, so if you have any, please, I'll be happy to answer them. So first, I've been a software engineer for 16 years and part of NBIO since 2018. Previously, I worked for the e-government and telecom areas before joining Mercedes-Benz IO, always on the back-end side. And my favorite subjects are Kotlin, Kubernetes, and distributed systems. So, who we are and what we do. So, Mercedes-Benz IO is a 100% subsidiary of Mercedes-Benz Group AG. And our goal is to develop digital products and services to support sales and marketing. These products include our own website, the car configurator, our online store, and many other products that are the backbone of the overall solution. So, dealing with so many services and products brings some additional challenges. So, why do we need an API gateway? So, one of the challenges we have with dealing with so many products and services, that all these services and products are developed by different teams, belong to different domains, and have their own independent infrastructure. So, looking at our diagram here, we can identify our three main client types: the car, representing the software running on the car, the head unit, the web browser, and mobile devices. And we have our clients segregated all around the globe. And for that, to provide a better experience for them, we make use of a CDN provider. In our case, we use Akamai, that provides us edge nodes across all the world. And these edge nodes are typically located in key locations, and the clients connect to the ones that are nearest to their region. So it provides a better latency for them, as other features that we make use of the CDN. But if we receive a request coming from the client, the CDN, the edge node, will then need to forward the request. And on the bottom, we can see multiple teams, completely independent teams, each one having their own cluster and exposing their own services, their own backends for frontends. And if we follow this diagram, we would immediately have a huge problem. So the attack surface would be enormous, because all services here would have to be exposed to the internet, and every team would need to implement all the concerns that come with being exposed to the internet. DDoS protection against bots, against scanners, certificate management, so a whole lot of concerns. And we would have also a duplication of concerns, because all these services typically have something in common. The authentication, course management, tracing, monitoring concerns that could be implemented on a centralized point. Otherwise, everyone would need to deal with these concerns. So we decided to implement an API gateway. So this API gateway resides between the team's clusters and the internet. And this is the only endpoint public to the internet. It is protected by an IP whitelist containing the IPs for all the edge nodes across the globe from the CDN, so we are only able to be contacted by them. And the teams, each team is able to publish routes that they want to have exposed on the internet. Once a client makes a request, it reaches the gateway, and the gateway, if it has a route, it matches the request, matches a known route, it will forward it to the corresponding service. So pretty standard for all the gateways. But what did we wanted to provide? So we wanted to provide a unique domain name as the central point for all our APIs, and wanted to provide a centralized CDN web application firewall point. So this is the point, if it's the only one that is exposed to the internet, this is the point where you actually configure all the rules. We wanted to provide flexible CORS mechanisms for all the teams to configure their CORS independently. We wanted to have internal path filtering, so the clients can segregate the parts of the API they want actually to be exposed to the internet or not. And the implementation of cross-cutting concerns like authentication, tracing, and others. But, and this is where we were going to focus most of our presentation here, we wanted one of our main concerns was how the teams were going to use our gateway. Because we now introduced a new layer between their services and the internet, and we wanted the experience for them to actually create routes and manage their own routes was as seamless as possible. So we actually wanted them to be completely independent on using this new system, so the way they publish their routes, and as soon as they apply their routes, the results are automatically applied. And this is where we will focus all our presentation on. So let's go to our solution in depth. So the first solution, the first iteration that we took followed this diagram. Down the presentation, I will show you the new version, but for now, let's focus on the first. So we have on the bottom our team clusters, separated teams, and we have team one developer from team one creating routes on a route management component API. So simple endpoint identification. This route management API persists routes on a MongoDB collection, and here the API gateway loads the routes from it. Pretty simple, pretty standard. Once a client request comes, the API gateway forwards the request to the one. Okay. So from that diagram, we could identify two main components. So first, the route management API and the API gateway itself. So let's focus now on the route management API. So this was the component that is pretty simple. I'm not going to talk a lot about it, but it provides a CRUD API for subscribers to manage their exposed routes. So this is the point where we actually make all the central validations. So if one team applies one route, we have to make sure that it's not overriding other teams' routes. All these type of concerns are handled here on this API, and it's an API key-based authentication. Every team gets an API key. It identifies the team, and the routes are their own. Only they can manage them. It was implemented using Spring Boot and Kotlin, and the persistence mechanism was MongoDB. So now let's talk about the API gateway. So one of the objectives that we had with the API gateway was achieving instant route reload. And the routes are completely dynamic. So a team can compose, we'll see how, route structure, and it's completely dynamic. And once it is persisted on MongoDB, we use a feature from MongoDB called the change streams, where the MongoDB sends us an event for every object that was changed on that request. So we are notified, and the API gateway is listening to it, and is performing an automatic route reload. So how was the API gateway implemented? So we made use of Spring Cloud Gateway. We use the reactive stack with Netty. Nowadays, I know there is already one where we could use virtual threads from Java 21, follows the MVC version, but at the time we used the reactive stack, and we are pretty happy with it. And we make use of already available filters that Spring Cloud Gateway brings out of the box. And the solution was implemented with Kotlin. So actually, if you want to know more about Spring Cloud Gateway, actually in the conference, we have the main developer from Spring Cloud Gateway. He's going to give a session on the afternoon, Spencer Deep. So yes, he's actually the maintainer, I think, the main maintainer from Spring Cloud Gateway. So what are the main features we have from the API gateway? So automatic route reload, using MongoDB change streams, where every change event triggers the route reload. And we have a programmatic and dynamic route creation, where basically what we do here is the model that we define and is stored in MongoDB, we will then make a mapper to the Spring Cloud Gateway route model. So it's a simple mapping between two objects. And we made use of the custom filters because they are really easy to implement, and extend your functionality and provide whatever concerns you want, business or not. You can implement whatever logic you want there. So let's actually look something in detail, see how it works. So first of all, this is the structure. First, we'll give a context of this demo. So this demo that we are showing, we made it specifically for this session, and it follows exactly the same principles that we have implemented and are running in production. But we have streamlined some of the concerns for this demo's sake, so it's a little more condensed. So everything starts with the team giving a name to the service. This object is called the gateway service, that we've called it, and contains all the route definitions. So the name of this gateway service is JNation, and now we have the route path of the route. So this route path is this path that comes immediately after the domain name, and can be seen as typically the namespace of a team's route. So once a team uses that route path, it's their own. Then we have the endpoint. The endpoint is the address where the gateway will forward the request to. And we have now the list of routes. And the routes have two fields. One mandatory, which is the match, which contains the route predicates. So this is where Spring Cloud Gateway will apply these predicates to a request and see if the route matches or not the given predicates. You can use here path, headers, whatever header comes on the request, and the methods, HTTP methods. Or you can implement your custom one. It's completely available for you to do so. And then we have the filters. This is not mandatory, but what is a filter? Is something that stands between your request and your response. So you can actually change the request before it's sent to the endpoint, to the upstream service, or you can change the response coming already from the upstream service. Or you can do whatever you want in that. But typically the filters change either of these ones. So in this case, we actually implemented a custom filter to show you how it's easy to implement. And what this static filter does is it sets automatically, once it receives a request, it sets a status code, okay? It can be any status code. In this case, we are not setting any others, and we are setting a body saying hello JNation. So it's not sending the request to the service, to the endpoint, it's intercepting and sending the response immediately back to the client. So now let's look at actually the API. So this is the route management API containing the typical endpoints that the team uses to manage their services. We have a gateway services. We can actually copy and check that we have no routes present at the moment. So as you can see, we have 0. And if I call the gateway, I get the route not found. Okay? Expectable, we didn't have any routes. So now, let's actually create this route. So, I execute. This status code should be okay. Yeah. And if I now reload, I get hello JNation. So as soon as I applied it, everything reloaded, the routes were reloaded. And if I now, for example, remove this filter, let's imagine that, okay, the team does not need this filter anymore for whatever reasons. Let me see, I'm changing on the wrong place. So I'm going to remove the static response filter and execute it. So, and now if I reload, it will eventually, let's see if the network helps, I should get the JNation website. Okay, I get the JNation website because no filter is coming. This just removes the filter. The strict, forgot to mention this filter, this strict prefix, removes the JNation part. So otherwise, I would send a request to JNation.pt-JNation, and no, I don't want that. I just want to drop that namespace, so to speak, that root path, and send the request. So okay, so also the delete it follows exactly the same principle. So if a team comes and deletes the route, immediately I should get a no phone. So everything is applied automatically. So how is this done? So everything starts at creating the listener. At creating the listener that will receive events, the events from the MongoDB. I'm not going to show you here just this gateway service, so this is how I define the model that matches that JSON. And I've created this model, now I have a MongoDB and I have a change stream, and this will get all the events coming from it, they will be collected, and now for each event, it will send an event, an internal Spring Cloud Gateway event, indicating that Spring Cloud Gateway needs to reload the routes. And this, as soon as Spring Cloud Gateway internally receives this refresh routes event, it will call a route locator. And this route locator is a custom implementation also, and this is where you're going to tell Spring Cloud Gateway where are the routes that you're going to load. And in our case, we just go to the repo, find all the routes, and then we are going to send to do that dynamic mapping, where we're going to change, to transform, to map the gateway service that we have stored into a Spring Cloud Gateway route. And this is just a simple map, where this is already the object from Spring Cloud Gateway. We just make a simple map. So you can add new filters, and as long as you map them correctly into your own filters, you can do this as you want. Just create the filters, the predicates, whatever you want. So this is just a simple mapper. Just to show you also how do we create a custom filter, just for curiosity, that static response gateway filter. It's pretty easy. Just need to implement a class that implements a gateway filter interface. It will force you to implement this filter method, and here, just implement it however you like, with whatever logic you need. So just implementing an interface, and that's it. Okay, so we have seen how this gateway service, the route management API and the gateway work together, and we are coming back now to the solution, to the solution that I have just showed. But we were not happy with this solution. Why? One of the main focus that we had was to actually provide the users, our teams, a good experience. They will do a good experience on using our gateway and managing their routes. So, considering that our ecosystem is Kubernetes, all our teams create their deployments based on manifests. If you know Kubernetes, it's all based on manifests, multiple manifests, creating an ingress, their services, whatever. And the routes are typically part of the deployment itself. So when you create the deployment, the routes should match. So let's imagine, you add a new endpoint that you want to expose to the internet, you would like that, once you apply that new version of the service, immediately there's a route deployed so you can access it. And if following this approach, it will not be easy. So the teams would apply it to Kubernetes deployments, and they would need to have like a synchronization process, either CI/CD or whatever, that invokes a management API endpoint. And this was not easy, not easy for them, and it was not developer friendly. So we decided to go on a different approach. So we decided to develop a third component, which is a Kubernetes operator. So how does it change on the architecture level? So from this moment, the team, the developers, no longer contact the route management API. Instead, they specify their routes as a resource manifest, like any other Kubernetes manifest. We'll see that in a minute how it's achieved, but they just create the routes manifest, and this Kubernetes operator is listening for changes on that of those resource types. And it's this component that is running on every cluster that is actually propagating, applying the routes directly on the route management API. So everything from for the user perspective, they only work on their own cluster. They never need to talk with any other external system. So we have identified the third component of our solution, which is the Kubernetes operator. So what is a Kubernetes operator? Kubernetes operator is a way to extend Kubernetes to actually do exactly what we want, to automate deployments. When you have custom things that you want to do on your deployment, Kubernetes operators really help on this, because you can actually automate multiple tasks on a simple and flexible way. And a Kubernetes operator works more or less in a very simplified view like this. So once a developer applies a resource on the cluster, the operator is listening for change events, so it's watching that resources of that type, and is able to automatically perform any custom behavior and apply adjusting the state if they need. So it works on a cycle. Also, worth mentioning, an operator is like any other service that you can deploy in your cluster. An application is running in your cluster just like any other, just has some specific details that you actually need to take into account. But generally speaking, it's like any other application. Okay, but now we said that we want to model routes as a Kubernetes manifest. So how does Kubernetes know? How do we want to model our routes? This is where a custom resource definition comes into play. So a custom resource definition is a native Kubernetes object that allows you to introduce custom objects inside Kubernetes, and also it will extend its own API with new endpoints that allows you to actually interact with those objects. So as soon as you apply that resource, we will see that in a minute, this, you can, if you use kubectl, you can make kubectl get that type of object that you create. So it extends the API with it. So let's look actually into one in detail. What is a custom resource definition? So, okay, so on the left, we have a custom resource definition, and on the right is then an instance of an object that we will be able to create using that custom resource definition as soon as Kubernetes knows it. So, if you remember, passing from the JSON solution for this one, it keeps the name. It's a gateway service. The gateway service is what contains all the routes that the team is going to publish. So, looking at the custom resource definition, it's exactly like any other Kubernetes manifest, where you specify a group, the group of your API in this case, and you will see the correspondence then appearing here on the API version, PT JNation, the name of the service, the resource, the kind, gateway service, and it has more fields. I'm going to pass it because it's at a lot of time. But then we come to the versions. And although a version, one custom resource object can have multiple versions, and when you want to actually create a resource of a given version, you specify it on top, like any other Kubernetes resource, we are going to focus on having a single version. So when you have a single version, you first need to give the version name, and then defining the schema. So defining the schema is telling Kubernetes what type of object is going to expect, the structure. And if you have used Swagger previously, you probably are familiar because it uses OpenAPI with schema to actually define the structure of the object. So if you look at this, we have, for example, a routing definition object. It matches the name, and this one contains a property called endpoint of type string, and it's here. So it's basically a mapping of this structure, so Kubernetes can know how to apply, what to expect. Okay, so now we have seen how to create the resources. So from the moment you apply that resource on the Kubernetes, the custom resource definition, you can immediately apply that resource type, the gateway service. You can apply it. But now, something needs to be done over that resource. And for that, that's where the operator actually kicks in and contains the logic that actually is going to perform stuff. So in our case, in our operator, what it does is a developer applies a gateway service, it is persisted on the Kubernetes API, and the operator here is watching for changes on that resource. As soon as it detects a change, it will call a method, something that I'll explain here what it is, reconcile that gateway service with the route management API. So what is a reconcile in Kubernetes terminology? So Kubernetes is constantly on a cycle, trying to make sure, and this is a phrase that you'll find everywhere, that the desired state matches the actual state. What does it mean? means that when you apply a resource, that is your desired state, so I'm applying it, this is how I want it. Kubernetes is making sure that the state actually matches what your desires. Let's give an example. If you know Kubernetes, it's easier. For those who don't, sorry. But when you create a deployment of type replica set with, let's imagine, 2 replicas, Kubernetes internally immediately scales up 2 pods to match your replica set number. If you reduce it, it will automatically downscale. So it's matching the desired state, so 2 replicas, should have 2 pods. And this is what the reconcile is. And what we are doing here on this reconcile is making sure that the gateway service that is applied by the developer matches exactly the same routes that are applied on the route management API. So what we are doing here, and this is important, and we'll see this working in a minute, is actually tying up the life cycle of the gateway service, of the routes, the routes for the team, to a Kubernetes resource. We'll see what this means in a demo. So, a Kubernetes operator. So how did we implement it? For those of you that are familiar with it, a Kubernetes operator, if you look across the internet, you'll find that most of the Kubernetes operators are implemented in Golang, but nothing stops you to actually use another language. So we decided to use a JVM approach using Kotlin, because our ecosystem, we have more experience in Kotlin than we have in Golang, and because if we didn't develop using Kotlin, I wouldn't be here, probably because it's a Java conference. So we use Quark as native. Why? Really important that, if you remember, the operator is deployed on every cluster, on every team's clusters, and we have multiple teams across the company. So if it's deployed there, we want it to be as lean as possible on resources, and as fast as possible coming up. So Quark as native, we were able to achieve this easily, and because it builds an artifact, a binary artifact, which is very low on resources, and it works pretty well. And then, to give us support, because implementing an operator is complex, it has multiple small details that you need to take care of, we used a Java operator SDK library, which is actually being developed very actively, and has a great community. And if you are interested, take a look, because it's really good. It serves all our purposes. And also, as a great extension, Quarkus extension to deal with. So it has a very good integration with Quarkus. It also has extensions for Spring, but we used Quarkus for it. So let's look at something in detail now. Oh, sorry. Let's look at applying something. So first, giving a context of what is our live demo here. So I'm running all 3 components here on my machine on a local Minikube cluster, just to make sure that everything goes well. There are no limitations in terms of internet, so everything is running here locally. And what I'm doing here is I'm going to apply this resource, contains some routes, directly on the cluster. So let us go back here to GBrowser. I'm going to reload it to make sure, no routes. So applying this, I applied it, and you should be able to see it. Okay, the JNation settings was created, and if I reload, immediately the routes are reloaded. So the resource was applied, but now let's see what actually Kubernetes did on the background. Okay, so this is the resource that is actually now persisted in Kubernetes. In gray, you can see here one important field, generation. And what is this generation? This is really important in Kubernetes, in operators terminology. This is a number that is incremented automatically by Kubernetes every time a spec, so the body of the resource, is changed. If you change the metadata or whatever fields, it will not be incremented. But this one will always be incremented. And as soon as you apply it, so it's the first version, it puts the generation on number 1. It's the first one, it's incrementing, the next one will be 2. And now we have a new what is called a sub-resource, a status sub-resource on the resource, on the main resource. I don't know if you guys can see there on the back. I'm sorry. It's okay. So here we say the status of the last reconcile cycle. So what are all these objects here? The structure of the status object is completely up to you. You can define the structure, whatever structure you want. But there are some key fields that are typically a best practice using an operator. And one of them is the observed generation. What is this observed generation? Basically, it identifies what is the last version that was successfully reconciled by the operator. So if our generation is 1, the observed generation is 1, it means that we have successfully reconciled and we are matching, everything is matching on the route management API. And then we put a date just to exemplify what was the last successful propagation. You can read propagation, it's reconciliation, it's a term that's used on both ways. Okay, but now comes a part where we all work, we are also probably all software engineers. Every time there will be an error. We can count on it, and there will be one error. So let's actually simulate to see what happens when we have an error. So, for this case, I'm going to simulate the following scenario. Let's imagine one team changes the routes, but the management API is down. So I cannot propagate the routes. What will happen? Let's see. So, if I can. Forget to set something, sorry. To simulate that the management API is down, I'm going to reduce the replicas to 0. So I'm running locally. So I am going to my deployment, my JNation deployment. I have 1 replica. I will reduce it to 0. It is applied. And now a team, so it's down. Let's simulate that everything is down. And now we're going to apply the resource. Sorry. So let's apply this resource, but with some changes. JNation 2024 as the text. So I will apply it, and the result was applied. Why? So you can see that it was configured. So no problem. Kubernetes lets me store the object. But what is happening? If I reload the routes, nothing was changed. Obviously, because the management API is down. So what's happening on the background? So on the background, we will have something interesting. The generation increased, for 2. We changed the spec, so we have increased it, but now the status contains some interesting information. So it contains the error of the last propagation, so in this case it's connect amount. It's not there, I cannot connect it to it. The date of the last failed, we will see this in a minute, why? And the last successful one. So when was the last time I could actually contact and apply it? But the observed generation doesn't match. It's a 1 instead of a 2. This means that the controller was not able to reconcile the resource. And what will happen? Now, on the background, I ask you to look at the last failed propagation field. You'll see that it's constantly changing. The last failed propagation here, it's constantly changing. Why? Because the operator is doing its best to actually make sure that the desired state matches the actual state. And it will keep on cycles. Cycles is everything configurable. You can define the maximum number of attempts, exponential backoff, demo service. I'm just trying every second. But you'll see that this is not working. So let's imagine a developer applied, tested the routes, it's not working, they're not seeing the intended result. They should always check the status because it's reporting here what was the problem. So now, if I come here and I immediately increase the replicas, workloads, deployment, sorry. So let's increase and let's see what happens. Now I should have 1 replica up, on the YAML. Let's keep reloading and wait. What is this? Okay, as you can see, it's still trying. Last failed, last failed. Still not up. And it eventually succeeded. Came up, and everything was recovered. Also, we can now check, for example, the route deletion. The route deletion follows exactly the same principle. If I delete this from this resource from the context, sorry, forgot to show. Hello, JNation 2024. So it applied, route reloaded. So now I'm going to delete the resource. Deleted, no routes already. So what was the biggest advantage that we have here? All the routes life cycles are tied to a single resource. And they are applied, refreshed automatically once the deployment is applied. So the teams can now model all the routes next to all other manifests that they have. No need to contact another external system. Everything is tied. And also, let's imagine, following the previous approach with them invoking through an endpoint, for sure, in so many teams, they would forget to delete routes. You'll start to have ghost routes on your gateway that don't have any owner, don't have any service already. Using this scheme, it will make sure that all the routes will be deleted and cleaned up as soon as the team deletes the resource. So how is this implemented? Just some small details, because it's pretty easy. So first of all, everything you need to do is, I'm not going to spend that much time on this, but, sorry. So, is implementing a reconciler. But first, remember that CRD, this huge CRD? Probably this was one of the questions that I was going to receive. Remember this one? All this gigantic file? Okay, we don't have to generate to write it by hand. There's already the framework, the operator framework, has already a mechanism that reads this model that I'm going to show in a minute. Oops, sorry. It uses this model that you define. I don't have time to go over everything, but you just extend a custom resource from Fabricate, which is a Kubernetes client, a JVM Kubernetes client, extend it, define the spec, define the status object, use these annotations, and it will be able to generate all that CRD for you. So this is just a model of that YAML that we have seen. But now looking at the reconciler, if you want to implement a controller, you just need to implement one interface. Called the first one that you always need is a reconciler interface, which is typified by the custom resource. This reconciler is the method that is called by the operator framework automatically as soon as it detects that there was a change. So it calls this method, passes you the object that needs to be reconciled, and in our case what we do is just invoking the management API to persist this route, and then we update the status object containing the last success. Okay, pretty easy. But this is the other case. This is the case where everything went well. If you want, because you may not, it's not necessary, it's not mandatory, to actually handle errors, you use the error status handler interface. And as soon as you implement this interface, you will get the following, you need to implement the following method. The context is not really important for this demo, so let's focus on the gateway service, which is the gateway service that failed to be reconciled, and the exception that was launched. So now comes an important distinction. So let's imagine that one team applied a route that enters in conflict with another team's route. So the object is valid, the route management is up, but there's a conflict. The management API will send you a 400, a client error. And there is no point in that case for the controller to keep trying to reconcile. Why? Because the team needs to correct it. There's a conflict, they need to actually change the resource and apply a new version. And for that, to make sure that the controller does not retry, you specify with no retry. So do not try to reconcile again, only after a new change. And if the team applies a new change, generation implemented, all the reconcile is called again. So this is important to note that if you don't want to retry, this is important as a node, and then otherwise you want it to retry, and you just patch the status containing the error code and what happened, and that's it. So pretty easy, just to update the error status code, and then the cleaner. The cleaner is to delete if you want to do something on delete, and we do, and it's also pretty easy, just invoking the delete gateway service. So as you can see, we have a lot of logic, but everything is implemented in under 100 lines. It's pretty easy to extend this behavior. I'm not showing you multiple configurations that you can actually extend the controller behavior, but this is just to give you an idea that this is how easy you can actually extend. Just deploying it, and that's it. Okay, so we are entering now the last phase. So just to give you some fun facts about our gateway. So this is actually live information. So we are currently serving an average of 1,000 requests per second and increasing. We have reached around peaks of 2,000 requests per second in only just a few gateway instances. Everything is possible due to, and really important when you develop an API gateway, to have horizontal port autoscaling with the metrics well defined. And then we have already 40 teams already using it. We have an average of 3 services per team and an average of 2 routes per gateway service. So it's already a lot of routes that we have published. So thank you so much for your time. If you have any questions.
So what you mentioned, so does it work? No? Hello. Yeah. I can get okay.
Yeah. I can repeat the question.
Yes. You mentioned that we are MongoDB, looking at your API of the gateway, and then we have the reconciler. So you have your source of truth in 2 places, which is the Kubernetes API and the database. How do you reconcile the things first and back? Because if you start from a new installation, you will need to populate the database first, maybe, or populate the Kubernetes first. How do you handle this?
So it's easy. So the team that, as if you remember, we gave a cluster to each team, and the team that actually provides clusters already contains multiple packages installed. So the first, as part of the landscape, let's call it the default cluster, we have already installed the operator. So that's the way the teams will apply it. So from that moment on, a team can apply the resource. We will contact the management API and store on the MongoDB. Like I said, if something occurs, for example, the management API is down, the team applies a new resource, so it doesn't match the state, correct? But Kubernetes Operator will try and try and try again. If someone goes directly to the API gateway, because they can go either to the route management API, Kubernetes, our source of truth is the Kubernetes manifest that is applied on the cluster. It's always the manifest, and it will override the routes. If they go there, because they can go to the management API directly to the Swagger and change the route there. But as soon as the operator kicks in, because you can configure and we have it, the controller can run also on a given time period without actually having an intervention. Exactly to overcome those errors, we configure the controller to actually run on a given time schedule, even if no change was performed on the object. So it will smash the results. So the source of truth is always the manifest.
Thanks.
Probably important to mention that since we use GitOps, so the state is actually in the Git side.
Yeah, the state is always, yeah, of course. The state is always on the GitOps side, so it's GitOps, so as soon as it is applied, yeah, so it should match. Go ahead.
Started by explaining the old kind of the older solution. Is that solution, are you still using it or are you
drastically migrated, but it's still available. If someone goes, because the only difference now is that we prefer teams to actually apply the resources. The Kubernetes will handle the communication with the route management API for them. But nothing stops them to actually go to the API and change it. But they need to be aware that if they change something directly there, and they have a routing manifest, a resource that enters in contradiction, the resource will be. I think that's all. Thank you guys. Have a good one.